1931. Guitarists have had a desire for years to hear the guitar at a louder volume. Then, George Beauchamp created the frying pan, the first electric guitar in history. It had a flat circular body and the neck represented the handle. Now, electric guitars have evolved into a much more sophisticated thing, as you can clearly see.
It is a special instrument because it belongs to two categories. In one hand, it is a chordophone because the primary source of sound are the strings on the instrument. On the other hand, it is an electrophone because it uses electricity. This instrument is electromagnetic as well because there are magnetic pickups on it that convert the vibration of the strings into an electric signal.
Wow!
The strings on an electric guitar vibrate when a guitar player strums, plucks, fingerpicks, slaps, or taps them, creating sound waves. But since electric guitars are solid and don't have a resonance chamber, the sound produced by the strings alone will be very soft. That is why you generally hear the sound of these guitars being amplified by an amplifier. Also, the strings on a guitar are somewhat elastic. That is why the more stretched the string is, the higher the sound's frequency is. But how is vibration of the strings transmitted to the amplifier?
Pickups are a very important part of electric guitars. The magnet in the pickups will magnetize the section of the steel string above it, giving it its own magnetic field. Then, when the strings vibrate, the magnetic field around the string will also move, inducing an electric current in the copper coil. Then, that current will go into an amplifier or into other devices with same functions like headphones, speakers, and others, where it will be electronically modified and then converted into a sound wave.
Converting an electric current into sound is fairly simple. Inside any device that does that, there are three major pieces: a cone, a magnet, and a copper coil. The coil is attached to the cone, and whenever an electric current goes through it, a magnetic field is generated. The polarity of the magnetic field generated by the copper coil will depend on whether the current is going in one way or another. And, since there is a permanent magnet there, the coil and the magnet will either repel or attract each other. This will make the cone go back and forth, and therefore, a sound wave will be generated, since air is moving. That sound wave will be much louder than the one produced by the guitar strings, and that is why you use an amplifier.
Wow!